Hey there, science enthusiasts. Today we're diving into the electrifying world of engineering. Specifically, we're going to explore two fields that might sound similar, but are actually quite different. Electrical engineering and electronics engineering. Electrical engineering deals with large-scale electrical systems and power distribution. Think of the massive power plants that light up our cities, or the intricate grid systems that bring electricity to our homes. Electronics engineering, on the other hand, focuses on smaller electronic circuits and devices, your smartphones, laptops, and even the tiny chip in your credit card. That's all electronics engineering at work. Both fields are crucial in our modern world. They work together to power our lives and keep us connected. Without electrical engineers, we'd be in the dark. Without electronics engineers, we'd be without our beloved gadgets. Let's take a quick trip down memory lane to see how these fields evolved. It all started with a spark, literally. In the late 19th century, scientists and inventors were just beginning to understand and harness electricity. This was the birth of electrical engineering. One of the pioneers was Thomas Edison, who laid the groundwork for large-scale electrical systems. Around the same time, Nikola Tesla was working on alternating current AC power systems. As we moved into the 20th century, things started to get smaller and more complex. The invention of the vacuum tube in 1906 marked the beginning of electronics engineering. The real game changer came in 1947 with the invention of the transistor. This tiny device revolutionized electronics, leading to the development of integrated circuits, microprocessors, and eventually the digital revolution. This is where electronics engineering really came into its own as a distinct field. Now let's zoom in on electrical engineering. This field is all about the big picture of electricity. Electrical engineers are the unsung heroes who keep the lights on. Literally, they deal with the generation, transmission, and distribution of electrical power on a large scale. One of the main focuses of electrical engineering is power systems. This includes everything from massive power plants to the transformers you see on utility poles. Electrical engineers design and maintain the complex grid systems that deliver electricity to our homes and businesses. They work on renewable energy sources too, like solar farms and wind turbines. Electrical engineers also work on large electrical machines and equipment. Think about electric motors in factories, the propulsion systems in electric vehicles, or even the electrical systems in aircraft. So the next time you flip a switch and the lights come on, remember, there's an electrical engineer to thank for that. Section 4. Electronics engineering, the miniature marvels. Now let's shift gears and talk about electronics engineering. If electrical engineering is about the big picture, electronics engineering is all about the details. It's the field that brings us the gadgets and gizmos we use every day. At its core, electronics engineering deals with the flow of electrons in semiconductor materials. These engineers work with tiny electronic components to build circuits that can process information, amplify signals, or control other devices. One of the main areas of focus in electronics engineering is digital systems. This includes everything from the microprocessors in your computer to the memory chips in your USB drive. Electronics engineering also plays a crucial role in telecommunications. From the antennas in cell towers to the circuitry in your Wi-Fi router, electronics engineers are behind it all. Section 5, Education Paths, Wiring Your Future. So you're interested in becoming an engineer? Great. Let's talk about how to get there. Both electrical and electronics engineering start with a strong foundation in math and physics. For electrical engineering, you'll want to look for programs that offer courses in power systems, electromagnetics, and control systems. Electronics engineering programs will focus more on digital systems, signal processing, and microelectronics. Both fields typically require a bachelor's degree, which usually takes about 4 years to complete. Many universities offer combined programs that cover both electrical and electronics engineering, giving you a broader base of knowledge. After your bachelor's, you might choose to pursue a master's degree or even a PhD if you want to specialize further or go into research. Section 6, Career Opportunities, where the currents take you. Now let's talk about the exciting part, careers. Both electrical and electronics engineering offer a wide range of job opportunities. The skills you learn in these fields are in high demand across many industries. Electrical engineers often find themselves working for power companies, designing and maintaining electrical grids. They might also work in manufacturing, developing electrical systems for factories or vehicles. Renewable energy is a growing field for electrical engineers with opportunities in solar, wind, and hydroelectric power. Electronics engineers are often found in the tech industry. They might work for companies that design computer chips, smartphones, or other consumer electronics. The telecommunications industry is another big employer with jobs in developing new wireless technologies or improving existing networks. Whether you're interested in powering cities or designing the next generation of gadgets, there's a place for you in the world of engineering.